Hello everybody. Let's talk about going from parametric equations like these to Cartesian equations. Okay, so what is a Cartesian equation, you might be asking? Though that's the name for the type of equation you've been working with your whole life. So y equals x squared is an example of a Cartesian equation. And a Cartesian equation is one where x and y are directly related to each other. So I plug in an x value, I can solve for y. I plug in a y value, I can solve for x. Parametric equations are different because x and y are both defined in terms of a parameter. Here the parameter is called t. So I plug in a value for t, and that gives me my x and my y. So x and y aren't directly related to each other. They're both related to this third thing called t. Okay, so if I'm going to go from a parametric description to a Cartesian description, it seems like what I need to do is go from two equations with a t to one equation with no t. So a convenient way to do that is to treat this as a system and solve it. So here I've written x as a function of t just to emphasize that x is determined, x is like the output when you plug in an input of t. But you can also treat it just like a variable. So let's just say the variable x is t minus 2 squared over 10, and the variable y is 10 minus t. So if you're going to solve this as a system, you could solve by substitution or by elimination. It seems convenient here to isolate t and then substitute in for t. So I'll add t to both sides. I'll subtract 10 from both sides. I'll subtract y from both sides. So t is moved there, y has moved here. Now we have a value for t, so let's plug that value in up here. So I'll say x equals 10 minus y minus 2 squared over 10. Or you could simplify that. Let's see, 10 minus 2 is 8. So 8 minus y squared over 10. And this is a perfectly sensible Cartesian equation. So perhaps you're not used to seeing x by itself on this side. Perhaps it would feel more familiar to you if I said y equals 8 minus x squared over 10. And this you'd recognize as, for example, a transformed parabola. So if you notice this rough sketch that we'd drawn in class the other day, which is the graph of the path for this parametric, you notice that it kind of looks parabolic. It's just like a parabola on its side. And that's exactly what this right here is defining. So just like way back in Algebra 1, you'd like make a table of values by plugging in numbers for x, like, you know, -3, -2, -1, 0, 1, 2, 3. You'd use the equation to get your values of y, and you'd plot your parabola. So you can do the same thing here, except you can plug in values of y to calculate values of x. So imagine for a second I plugged in y equals 8. I'd get 8 minus 8 is 0. 0 divided by 10 is 0. So what that tells me is that x is 0 when y equals 8. But instead of plugging in x and solving for y, I plugged in the y value and solved for x. But it still describes this point right here, 0, 8. So we're still describing points on the curve. If you really wanted to, we could isolate y from here instead, and maybe that's worth just looking at to see what happens. So let's multiply by 10. So now I've got 10x equals 8 minus y squared. I'll take the square root of both sides. So now I've got plus or minus root 10x equals 8 minus y. Let's add y to both sides and subtract this from both sides. So here I've got y equals 8 plus or minus root 10x. So hopefully you recognize that as being this shape. Here let me redraw it down here maybe. So the 8 is me having shifted the y value up by 8. And then I've got plus or minus a square root. So the positive square root would look like this. The negative square root would look like that. And that's exactly what we have up here. It's just that with the restriction on t, we cut it off here and we didn't look at this piece of it. So so the main lesson here is solve the system to eliminate t, and that will give you a Cartesian equation which describes this curve. An auxiliary lesson is how do you think about an equation where you have x by itself? And the answer is you can think about it either as plugging in y values to get x values, or you could solve it, or you could isolate y to get a more familiar looking equation. Notice that this is not a function because it's failing that vertical line test here, But all of these, this and this and this, are three different ways of describing that same path.